today I'd like to talk to you a little bit about soil improvement with cover cropping. This is part of a research project we have going on with Dr. Brandenberger and Dr. Hailan Zhang, the director of the soil testing lab there on campus. Okay, so cover cropping, you know, we've gone over this today plenty of times, but basically that's a crop that's going to be cultivated in order to turn it back into the soil. It's not your cash crop, it's what we're trying to build that soil up with, hopefully. It's what we're trying to give some more nutrients to the cash crop as it's going to be put in. The term for that I remember hearing growing up was green manures. Okay, so that's kind of an old term. So essentially, when we're talking about cover cropping, probably the biggest thing, one of the biggest things we're talking about is the addition of organic matter back into the soil. Okay, we talked a lot about weed suppression in some earlier presentations. That's a great thing that it can do. But we're really trying to look at improving the soil health and quality, and we're looking at those physical parameters of the soil. Are we looking at good water infiltration in the soil, good soil structure? Okay, that all leads to having better water infiltration, like I said, water holding capacity, nutrient holding capacity. That's what we're hoping for with that. Microbial population, we're hoping that's going to increase and also increase our microbial diversity. A question that we're going to be dealing with is, does that really help with your crop yield? It also helps with the chemical properties, meaning the soil fertility properties. Okay, you're adding a lot of nitrogen with that organic matter. That organic matter is helping to transform a lot of nutrients to make those things plant available to your cash crop. We also talk a lot about sustainability, and that's kind of a word I think is better than organic. But we're talking about trying to improve the long-term health of that soil, hopefully, in the future. And again, does it improve crop yield? Sometimes, okay? So we're hoping to make that be more of an all-the-time type thing, okay? Organic matter is the living microorganisms in the soil. A lot of those microorganisms, when we think about, that's kind of a smaller part of things when we say soil organic matter. A larger part is that detritus and decaying plant and animal matter, residues that are contributing nutrients back into the soil. So really, part of the decaying part is really more of what we're talking about with soil organic matter. And those things are cellulose and crude proteins. Those break down very quickly in the soil. And then when you get with hemicellulose and lignin, those are very slow to break down. So you're not going to have as much a quick turnaround on nutrients being released back into the soil from those type of plant structures. And so again, as we talk about organic matter, we want to build that back up. Okay, so late 1800s, before things were really starting to be plowed up, Oklahoma is estimated had about 4% organic matter in the soil. Okay, that's relatively unheard of now. Okay, so we come in, we have the land runs, and we have people farming and plowing up everything, and the Dust Bowl and all that business. And now we're down to less than 1%. Often that's 0.5% or 0.7%. Okay, so that's really low organic matter. We've lost it all in 100, 150 years pretty quickly. All right. With that loss of organic matter, there's a lot of loss of nitrogen as well. Okay, so all that just went in the grate. So as we talk about soil physical properties, we're looking at improved soil aggregation. Okay, meaning the structure of that soil is strong. It's not very I don't want to say crumbly, but we'd say we want it to be friable, which means that it breaks pretty easily, but we don't want it to be dry enough just to blow away with any wind. We want it to be stable. If it's got water coming into it, we want to be able to take water in well. We also want to be decreasing soil compaction and bulk density. Okay, that's root restricting, that's water restricting. It keeps water in the top, whether it's easily evaporated or easily run off, and not kept deeper into the soil profile where those roots we'd like for them to be heading down that way to be mining for some more water. So again, wind erosion, another big problem. We can see this in some of our plots and on the farm. When I first started there at the research station, the manager there was really big on disking everything. And it would just drive me crazy because you'd stand there in the summer and just these dust levels are blowing up all the time. We're right there on Highway 33 and 177. A lot of times it's blowing across the road. It's just not something you want to say, hey, we're the university, we know what we're doing, and all this is just leaving. Okay? It used to drive me nuts. So, also with water, again, we talked about water infiltration. You want good water infiltration. If there's just bare soil there, the impact of a raindrop can really cause a lot of damage. A lot of surface crusting, a lot of runoff, that impact of a raindrop. So as we talk about increased nutrient retention, increased nutrient availability, we want those things to be plant available. We don't want them to be there necessarily in a organic. We want that mineralization to take place, for them to become inorganic, for them to become plant available. Your organic matter is going to be a good catalyst for that, okay? Making things available where the plant can take them up through the roots, okay? Making those nutrients, again, available to the plant. Microbial population and density, again, we've seen that increase with cover crops. Just trying to figure out how much of that is really beneficial to the crop yield, okay? It's very good for the soil health, but where does that translate when we're trying to get an economic return on things? We talk about carbon-nitrogen ratios. Josh mentioned the carbon-nitrogen ratio of 80:1, not very good, okay? So if you have a high nitrogen ratio, and that's about 30:1 or higher, you're not gonna have nutrients available to the plant. That's gonna be causing more immobilization happening, making those not available to plants. You want to plant cover crops that have low carbon nitrogen ratios, less than 20:1, to encourage mineralization to be happening, to make those nutrients plant available so they can be taken up. You don't want them tied up in microbes or other organic fractions that aren't going to be able to be available to the plant. Part of what we're doing on our project is looking more at soil health evaluation testing. There's already some very good resources on this. Oklahoma NRCS has a very good soil health evaluation assessment card. It's just a good visual tool. A lot of these things can be done with a trained eye, and you can tell, what's better and what's worse just by looking at it. We're trying to take that kind of to the lab and be able to do that a little more analytically as well. Alabama, their soil testing already offers a soil quality index with their soil test. That's kind of what we're trying to move towards. Okay, so they're looking at cover cropping, they're looking at what's your microbial biomass in the soil, where are some of your nutrients coming from, to kind of give a good overall soil health quality, and then to have recommendations to improve that if needed. Cornell has a similar thing, and that also Haney method as well is used a lot in Texas. So we're looking at those things, trying to incorporate those things for Oklahoma. So the NRCS field card goes in with soil structure, aggregate stability, has a good way you can just measure that on there with a ruler. Talk about how large your aggregate sizes are. Talks a lot about organic matter, going off how dark the soil is. Has a good compaction, looking for macrofauna, water infiltration, plant health, and percent cover. So again, it's just a good visual tool you can pick up. Here's an example of the Alabama soil health scoring. So again, they're looking at cation exchange capacity, pH, phosphorus, potassium, base saturation of cations, organic matter, measuring microbial activity by soil respiration, looking at the nitrogen mineralized with that, and aggregate stability. So basically they've got a score going from 1 to 100. The closer you are to 100, the better your soil is. We got recommendations in there as well. So that's kind of what we like to move to for Oklahoma, to be able to offer that. To do this, we've got a study where we're strip tilling into cover. So this area has been cover cropped since about 2015. Prior to that, it was an old peach orchard, and then it was in just Bermuda grass cover for several years after that. The crops we were looking at are spinach, cowpea, and sweet potato. So this is kind of our general setup. We've got a rotation of winter and summer cover. First one there on your left is cereal rye crimson clover winter cover. We're switching that over to sorghum Sudan and cowpea in the summertime. And then we've got wheat crimson clover and then forage cowpea in the summer. The third one we've got is cereal rye winter pea tillage radish. And in the summer, we're doing pearl millet and forage cowpea. And then our fourth one to kind of check anything on is just kept clean fallow. So this is just some pictures, example of how we've got this set up. There in the middle, the strip till there, that's directly after we planted spinach. So nothing's come up. Unfortunately, with the rains this year, that's almost how it stayed looking. We had very heavy rains immediately after planting, and I think a lot of that seed just got pushed down too far to come up. We've also noticed in our cereal rye block especially, we're pretty sure there's some allelopathy going on there with the cereal rye affecting the spinach. That was definitely our poorest stand coming up in comparison to other poor stands. But we're kind of looking at that as maybe something we don't want to use as a cover crop for that reason. And again, here's cereal rye winter pea mix and tillage radish, and here's our fallow. Now, I hate to say it, but our fallow had the best spinach stand, which is not what I wanted to report necessarily, but that's what happens sometimes. On our chemical properties, we're going to be looking at mainly macronutrients, nitrogen, phosphorus, potassium. We'll be looking at soil pH, looking at soil organic matter, and then looking probably at electrical conductivity of soil as well. So our organic matter is really what we've got the most data on right now. We're still working through some of our yields. We just harvested cowpeas last week. And we'll hopefully be harvesting sweet potatoes here in the next week. On physical properties, right now we're doing aggregate stability through wet sieving. We're looking at saturated hydraulic conductivity, infiltration rate, and we're looking at soil compaction through a penetrometer. Okay, so I'm not quite expecting to see real differences between the cover crops themselves on some of these physical properties. Those are things that take a while to develop. Just trying to look at those and trying to make sure, hopefully, that at least we can show some differences between the fallow and the cover crops themselves. On microbial activity, we're going to be looking at carbon dioxide respiration measured through gas chromatograph as an alternative to Solvita, which is a product that measures that as well and is used in a lot of these soil health assessment tests offered by labs and universities. On our cover crops, we're trying to look at what biomass is there, okay, how much is there. Trying to look at that sort of the easiest way we can. And I say that in that it's hard enough to get people to soil test. I don't know about adding other things to try to get people to do. So there's an app called Canopio, which you go out and you take a picture of your crop, and it gives you a good percentage cover on what you've got over what bare ground is still there. Okay, so we're trying to use that and trying to use our biomass yield that we're actually harvesting, correlate these two things, so we can just go out and take a picture of it and be able to say, okay, I've probably got this much. How much nitrogen is going to be there? What am I really adding back to the soil? On our vegetable crops, of course, we're trying to look at yield. We're also trying to look at nutrient quality of those vegetable crops versus marketable yield. Okay, so how much is there by weight how much is there that could really be sold and really be usable. So our organic matter, all right, this has been in cover crops about 5 years. Okay, the first year we did this, took soil samples, and we had pretty high organic matter. Okay, that is likely from the Bermuda grass that was there before. Okay, so we don't really want to count that yet. And you can see here as well, our fallow still has, in the next year, has the highest organic matter. Okay, again, still trying to get that Bermuda grass out of the fallow to start this up. Okay, as we move along, we can see increases in the cover crops, but our fallow, still frustratingly enough, is the highest. Okay, so the persistence of Bermuda grass is a serious thing. So normally, if we're trying to start something on the research farm, somebody says, well, we need somewhere that's not in Bermuda grass, I like to know that about a year ahead, so we can start trying to kill that out and start trying to get that out of there. So this year, we finally really see our fallow is the lowest on organic matter. Okay, it's still not too bad as far as organic matter goes in the state. But we do see our cover crops are building up the organic matter in the rest of it. That's something you can see visually compared to other places on the station. The soil has remained darker there. The soil is not blown away there as many parts of the station have. It's a pretty sandy soil throughout that whole station. It's on the upper stream terrace of the Cimarron River, so we're pretty sandy. But we are seeing the organic matter slowly come up, and hoping that continues and can give us some good data down the road.